Now let's do a quick review of complex numbers. We're going to be using complex numbers a lot in this chapter 7 on AC analysis. So I recommend that you get your calculator handy, the calculator that you plan to use on exams and homework. I recommend that you get it handy right now so that as we go through some of the examples, you can press the numbers into your calculator and check to make sure that your calculator is working as anticipated. So we find it useful to represent sinusoids as complex numbers, and there's multiple ways to represent complex numbers. There's the rectangular format and the polar format. Now, when we're in this electrical engineering class, when you're taking this electrical engineering class, do notice that this very simplified format is often a common way for electrical engineers to write the magnitude, so that's the absolute value of z, and the phase, that's the angle theta. This is equivalent to writing magnitude z multiplied by e to the j theta. Another thing that you should note for this class specifically is that we call the imaginary number j as electrical engineers. Now, why do we do that? Well, we already are using I for current, so just so that we never get confused, electrical engineers tend to use j. If you're typing into MATLAB or something else on your calculator, you may still need to use I, but whenever you're writing down an answer or reading a complex number in our textbook or any electrical engineering textbook, anticipate using j as the imaginary number. So why are there two ways to write imaginary or complex numbers? So the way that you can think of this is by putting them onto an axis where the imaginary axis is the y-axis and the real is the x-axis. In the rectangular format, x would be the magnitude in the x direction and y would be the magnitude in the y direction. Now, we can clearly see from this that this, by plotting x here, so going out to x here and then up to y, we can clearly see that this would also create a triangle where the hypotenuse is the magnitude and the angle is theta. So because of this, right, this is why we can write our imaginary or complex numbers in both rectangular and polar coordinates. And there's a lot of reasons that we may go back and forth between the two. Now, if you're doing it by hand, we have these relationships that you can use to go back and forth by hand. However, on your calculator, you can also change the mode of your calculator in order to get your calculator to automatically do those conversions for you. Now, in all of these relationships, those are summed up by this table of complex numbers. And then I recommend, again, that you have your calculator handy so that you can practice these. This table is included on that Phaser cookbook, which is on our class Moodle page.